Okay, hello students. You're welcome to Waidsum University. Now we are in this course, networking session management, and or you can simply say networking sessions. We're in chapter 4, part 5 today, and this chapter take a look at configuring a point-to-point wireless LAN, and we're looking at a case study. Probably a home study or a networking in an office area. Okay, without much ado, let's begin. Okay, first of all, the introductory part of this chapter. Now we say this chapter or this section of this chapter presents an example of preparing a proposal for providing a point-to-multipoint wireless network for a company. Okay, so you as an administrator, this section of the chapter is just a proposal that you have written on how you can provide a point-to-multipoint wireless network for a company. Now, the administrator for the company has decided that it would be beneficial to provide a wireless network connections for their employee back to the company's network. Okay, they have decided, the administrator of this company have decided that it will be beneficial for them to provide a wireless network connection for their employees back to the company's network. So they are using their company's network to provide the network for their employees. So this is the introductory part. So remember that this part is just like a proposal that's been written on how we can provide a network for our area, a point-to-multipoint network in our area. Now let's move on. Now we'll be addressing issues and problems in the following regards. We'll be conducting an initial antenna site survey. We will first of all locate an area where we can site our antenna. Okay, so we will be doing initial antenna site survey where we can locate our antenna, okay, for our home network. Okay, then another thing we're going to be doing in this chapter or in this section of this chapter is we will be establishing a link from the home network to the distribution point. Remember, the distribution point in this regard is our antenna site survey. Okay, the place where we're going to mount our antenna that brings a signal, radio signal to our distribution point, or that brings a signal to our home network, okay, from the distribution point. Another thing we'll be looking at in this section of this chapter is how to configure, or the method of configuring the multi-point distribution. The method we're going to be using, the antenna types that we're going to be selecting, okay, in configuring the multi-point distribution, which is our antenna site survey area. Okay, the place where we'll be mounting our big antenna. Okay, then another thing we'll be looking at in this section is conducting an RF site survey for establishing a baseline signal level for the remote wireless users. Okay, we will conduct an RF site survey where we can have the reception of radio frequencies, where it gets to in our homes, and which place should it be. So we'll be conducting an RF site survey for the establishing a baseline signal. So establish that the signal really gets to the home area for the remote wireless users. Okay, remember, we are making it for our employees in our companies. Okay, then the last part we'll be looking at in this section of this chapter is how to configure, or the method of configuring the remote users installations. How we're going to install the network for the users in point to point in the home buildings. Now let's move on to the next section. Now here is the antenna site survey. The first section that we are looking at is the antenna site survey. Now, if this is a river, or you can call a river valley, and this is our flat land, okay, this is our land where we have our home. Okay, this area is where we have our home. You can see an antenna, a Yangi antenna located on this building, a Yangi antenna which is radar located on this building. And this antenna, from this antenna to another antenna, probably a Yangi antenna or any omnidirectional antenna, because for the distribution point we need an omnidirectional antenna. Now for this place, the distribution point, usually on a very tall building or on top of a mountain, we can put it on mountain top, this big antenna, the distribution antenna. And this distribution antenna has a coverage area of 12 kilometers. To this direction, 6 kilometers, a clear view of about 6 kilometers to the right and 6 kilometers to the left side. Okay, a very clear view. So we mount a big antenna here. Yeah, in many cases we say, for mobile communication, we say the GSM mask. You say the big GSM tower, the GSM tower. Okay, this is what we're referring to, and this is your home. Okay, this is your home network, and this is probably your telecommunication tower or your telecommunication tower. Okay, that is mounted either on a mountain top or built very high in order to have a very clear view. About 6 kilometers. 6 kilometers is not a small distance. 1 kilometer is 1,000 meters. So 6 kilometers to the right direction as a clear view, at least minimum, or it could be 7 kilometers, 8 kilometers to the right, and 7.5 kilometers, 7.5 kilometers left and right, clear view. However, from your home, the distance, maximum distance allowable for a Yankee antenna to the distribution tower is like around 1 kilometer, so that the signal coverage from the home networks to the proposed antenna site where we are mounting the big antenna, it's 1 kilometer in range. Okay, now let's take a look at what we have. Here is a mountain range. Okay, here is a mountain. Okay, before we can do anything, at least we know that these connections can cover 7.5 to the right, 7.5 to the left. But as it were now, we use 6 kilometer range left and right. Okay, the proposed antenna site is on top of a hill. Okay, so this one was built on a hill. This was just a hill. Okay, so because the reasons why we are building on, in some places they put it on building top, rooftop. They put it on tall buildings like several floor buildings up to 7 floor, 8 floor, 10 floor. And in most cases where you don't have tall buildings like that, you put it on a hilltop. And there are some places where you don't have hills to put it. You don't have tall buildings and you don't have hills to put the antenna, the proposed antenna on. And then you have to put what we call a tower. You have to build a telecommunication tower. Okay, that they can have a clear view of at least 6 kilometers in all directions. 6 kilometers in all directions. Is that okay? Okay. Now we say the proposed antenna site is usually put on the top of a hill, approximately 1 kilometer from your home network. Usually 1 kilometer from the home network. Around 1 kilometer from the home network. Is that okay? Now a site survey of the proposed antenna site provide the following information. Now let's take a look at if you carry out a proper site survey of an antenna site. Let's see some of the information that you're going to come up with. Now the first thing is that the site has a tower that can be used to mount a wireless antenna. So you must first of all have a tower that you can use to mount the wireless antenna, because if there is no hill or a tower, then you cannot have a clear view of 6 kilometers in all directions. You cannot have a clear view of 6 kilometers in all directions. Maybe your view, because we need a line of sight. We need a clear line of sight. If you don't have a very tall place to mount the big antenna for the telecommunication distribution point, then the problem you challenge is a forest might block you if you're in a forest area. A mountain might block your view if you are in a mountainous area. I'm just telling you the challenge. Or a tall building like 20-something stories or 20-something floor, a condominium or what you call a skyscraper might just block your signal. Okay, that's why you have to put it on a hill, or you have to put the proposed telecommunication antenna on a hill or a mountaintop, or even on a big tower, a tall tower. Okay, so that to reduce or mitigate against the problem of signal reflection, signal degradation, signal blockage, and so on and so forth. Okay, so these are some of the reasons why we look for, and so that it can go a long range, signal can go a long range before it gets to another telecommunication closet or another telecommunication distribution point that can receive the signal to the home, in the next home where it's being needed. Is that okay? Now let's move on quickly to our next point of contact. Now we say besides talking about one of the things that you have a site that has a tower that can be that will be used to mount the wireless network, a site with a tower. Okay. Besides that, another thing we're looking at, the site has a small building and available rack space. There must be a building where you have all your telecommunication closet, and a rack space for setting up your wireless networking equipment. You must have a small building. The building could be built with a cabin, could be built with container. You know, these shipping containers. Probably you can use such thing. You can use a cabin. You can use real bricks to build a small building. It's a small building where you have all your networking equipment set up, okay? Where you can set up all your networking equipment. Then again, there is a clear view of the surrounding area of about 6 kilometers in any direction. That's in all directions. 6 kilometers, a clear view of about 6 kilometers in all directions. If you don't have this kind of clear view, then you are not. Then that area where you are mounting your antenna, it's not a clear area. It's not a good area for that antenna that you're mounting. So that's why you have to do a site survey to see where the antenna should be best suited in order to cover a given geographical area. If you go to a site, a place, you want to provide network for people within an area, you must do a site survey to know where, if you mount the antenna, it can cover at least 1 kilometer in all directions in case there are multi-users or multi-point users in that regard. So you at least to the homes. Then the antenna can cover at least minimum of 6 kilometers to everywhere in that range. 6 kilometers to all direction and everywhere and anywhere in that given area. Okay. Now there is not an available wired network connections back to the home network. Okay. There is not any available wired network back to the home network. So we should ensure that we are covering the range of 6 kilometers in order for us to be able to establish a network, okay, or to build an antenna in that given location. Then number 2 we are considering is establishing a point-to-point, what we call the point-to-point wireless link to the home network. Point-to-point wireless link to the home network. Now here is our home network. This place is our home network. This is our home network. Okay. Now from here, from the home network, we have what we call the wireless bridge. We connect a bridge, okay, to this. From the bridge, wireless bridge, we connect our antenna, a Yankee antenna that can establish a point-to-point link to another Yankee antenna that is built on the mounted top. Another antenna. This is an antenna that is built on a mounted top or a hill top. A mounted top or a hill top. Okay, so or a tower. If there's no hill for you to build, you build a huge tower. Okay, so this one, there must be a point-to-point connection between this antenna on our home that's connected to our bridge. The bridge has this antenna. Okay, the bridge has this antenna, a Yankee antenna that establishes a point-to-point connection link with the antenna that is built on a hilltop that's covering the area, the geographical area. Now, you can see channel 1 uplink it's already established. There is an uplink channel already established, and it's 11 megabit per second, which means it's 802 IEEE 802.11b. IEEE 802.11b standard that we're using in this regard. Okay. So I will set up this. One of the issues we have, or we will have, is that the cost of the link to the home network, the cost, what it will cost us to have established this tower and link it to our home network. Is that okay? Now let's move on to the next establishment. Now the antenna selection. Let's look at the type of antenna that we go to select, because there are different types of antenna. 3 possible antennas we will be able to select for this kind of connections are listed below. on this table 4.4. Now, let's look at the type of antenna, and we look at their radiation pattern, the type of radiation pattern they operate or they use, and then the range they cover, and then we look at the cost. And in the range they cover, we look at the type of speed, 2 megabit per second, or are we looking at 11 megabit per second? Okay, but I think for establishment to a home, if we're looking at establishing to a home, I think a 2 megabit per second will be enough. Home to this place, from the mountaintop or from the hilltop where you've established your tower together with your antenna, Yankee antenna, to your home network, I think a 2 megabits per second to the consumer or to collect is enough. It's enough, because 11 megabit per second might be super too much. Okay, so having said that, we will look at whether we're looking at 11 megabit per second or we're looking at 2 megabit per second. Now let's take a look. We have what we call the omnidirectional antenna. Omni type of antenna means antenna that radiates in all direction. Omnidirectional, in all direction, a 360-degree view. This type of antenna has what we call a 360-degree view. They can transmit and receive at 360 in all direction. Okay. Now if we're looking at the 2 megabit per second speed, then this type of antenna can cover a range of 7 kilometers, okay, in all direction. If you're looking at a less speed, then you have a higher distance. If you're looking at a less speed, you have a higher distance. So this type of antenna can cover 7 kilometers. So 7 kilometers in all direction. 7 kilometers in all direction, which is superb. If you're looking at 11 megabit per second, then it can cover 2 kilometers in all direction. This Omni antenna can cover 2 kilometers in all direction if you're looking at a speed of 11 megabit per second. Okay, now the cost is moderate. It's considered to be moderate. Okay, not too low and not too high. The cost of establishing or setting up this type of antenna is said to be moderate. It's not too high, neither is it too low. Now let's take a look at a Yankee antenna. When you take a look at a Yankee antenna is directional antenna. Okay, signals goes to a specific directions that they transmit to a specific direction that you set it to, or receive signal from specific direction that you set it to. Now, a Yankee antenna, if you're looking at the 2 megabit per second, then it can cover 12 kilometers per second. 12 kilometer distance range. If you're looking at 2 megabit per second, it can cover a range of 12 kilometers for you. And if you're looking at 11 megabit per second speed, then it can cover 7.5 kilometers for you. So it depends on which speed you're looking at, and that will establish for you a distance range that it can cover. And then for Yankee antenna, they are also considered to be moderate. The cost of establishing a Yankee antenna is also said to be moderate. Now, if we're looking at a dish is highly directional. Dish are highly directional antenna. And then if you're looking at the speed of 2 megabit per second for a dish, then it can cover about 38 kilometer range. It can cover a 38 kilometer distance range. Then if you're looking at the 11 megabit per second speed, then it can cover for you, it will cover for you about sorry, I think my volume was it will cover for you about 80 kilometer range. Okay, so and it's said to be high. The cost is said to be high. The cost of establishing this is said to be super high. Is that okay? Now let's move on to our next section. We say that the antenna selection. If you take a look at this, this is figure A. Antenna A has what we call the omnidirectional. A has what we call the omnidirectional. Remember, we've mentioned omnidirectional type of antenna. This A is omnidirectional, which means it covers 360-degree range. It covers 360-degree range. It can transmit signal to this direction, 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 to this direction. So the omnidirectional antenna radiation pattern, it covers everywhere. This means that the antenna can receive and transmit signal in a 360-degree pattern. It can receive and transmit in 360-degree pattern. Now let's take a look at the second one. The antenna B, figure B, if you look at figure B, then we say the antenna type is a Yankee antenna with a directional radiation pattern. I showed directional. So it can receive signal from this direction only. This direction, this direction only. That's where it can receive. It's not a 360-degree. Okay, it's a directional antenna. Then C, if you look at C, antenna C, this is highly directional. This is highly directional. Can only receive signal from this way, this direction. Okay. And C is a dish. It's a dish, and it's called this antenna is a dish antenna or a parabolic reflector. What do you call a parabolic reflector? These antennas provide extremely high directional gain. The cost of this dish antenna can be quite high relative to the cost of Yankee antenna and omnidirectional antenna, as we've established in the table here. We say the cost of dish antenna is high. The cost of this dish antenna, establishing a dish antenna, is high. Now let's move on. Let's take a look at the pictures of this antenna. Here is a Yankee antenna, which is a directional antenna. Okay, a Yankee antenna, which is directional antenna. This is omnidirectional type of antenna, which receive and transmit in all directions. And then here is a parabolic dish antenna, Okay, here is what sector antenna. This is just a sectorial antenna. Okay, this is a sectorial antenna. These are types of antennas we've looked at. Now let's take a look at step 3. Step 3 is called the configuring the antenna site for multi-point distribution. Now let's take a look at how we survey or we configure the antenna site for multi-point distribution. Now at this point, we say an 11 megabit per second wireless data links has been established with the home network. So 11 megabit per second wireless bit data has been established with the home network from the antenna that we've sited on the mountaintop or on the hilltop. So the link is 11 megabit. We've established an 11 megabit uplink. Okay, we've cited that earlier on. We've established 11 megabits with the uplink. Look at it. Let's quickly have a look at it again. Okay, you see here we have what we call 11 megabit per second in the uplink between this big huge antenna and the home antenna. Okay, let's go back to where we are. Okay, quickly. So we have established 11 megabit per second data speed with the home antenna network. Now the next task is to configure the antenna site for multiple distribution. The next point, what we need to do is to configure the antenna site for multi-point distribution, so that we can distribute to several. Because if you set up the main antenna on the distribution point, then it will have a multiple distribution. We'll be able to distribute to other home users. Now it was previously decided that a 2 megabit per second link would be adequate for the remote users. So for remote users, a 2 megabit per second is enough. It's super enough for remote users. For downlink, for the remote users. Okay. Now this decision was based on the data rate to be supported for the planned coverage area. Now the site survey in step 1 shows that there is a clear view of the surrounding area for 12 kilometers. 12 kilometers in this regard means if you're looking at a line of sight, 6 kilometers to the right, 6 kilometers to the left. 6 kilometers to the right, 6 kilometers to the left. Okay, as provided in table. Now antenna A, which is provides an omnidirectional radiation pattern, that one can cover about 7 kilometers in all directions. Okay, so if you look at a single line of sight, then you have a 40 kilometer if you're using antenna A. Okay, so because it has 7 kilometers in any direction. So if you look at a straight line of sight from away to and from away from the antenna, you have 40 kilometers. This satisfies the coverage area of about 2 megabit per second. So, you know the speed. If you choose it 2 megabit per second, then the coverage area is about 7 kilometers. Okay, so let's move on quickly for the sake of time. Configuring the site. Now, how do we configure the site? Antenna A, which is omnidirectional, was mounted on the antenna site tower. So the site tower, you mount antenna A, the omnidirectional antenna. Why? Why do we have to mount the omnidirectional antenna? Because we need the omnidirectional antenna because we want the transmission and reception to be in all directions. okay, from the tower, because people's houses can be in any direction from the tower. People's houses can be located in any direction, from the tower. So we have to use an omnidirectional antenna on the mounted top, okay? While we can have a Yankee antenna in our home-based network, okay? Now, an RF site survey of the plant coverage area was next done to verify the signal quality by the antenna selected. So we carry out what we call the RF, which we learned in 4.4 in our previous section, RF site survey. What we learned last in our previous section, we also did it here in order to see the measurement that we have obtained or made from the multiple locations within the coverage area. And here are the results. Okay, now the results we see here in one location was select. Okay, you can see the Interpro wireless LAN PC card from a particular local area network. You can see the signal strength is like 100 select. Okay, is in range, and the transmit speed is 2 megabit per second. Okay, so you can see this was super good. Okay, now another location was a weak signal, a poor signal. Okay, it was a poor signal in another location, maybe a little bit further away from the transmit antenna, from the main antenna. Is that okay? Okay, now let's move on quickly. Now the next section is configuring the remote installation. Now the antenna for the remote user, that's your home network user, only needs to be able to see the multi-point distribution antenna. So the antenna you need is just an antenna that will be able to see the multi-point distribution antenna. The multi-point distribution antenna is the main distribution antenna that you placed on the network, on the telecommunication antenna. Okay, the main telecommunication antenna. So, but your home antenna is just an antenna that can see the multi-point distribution antenna sites. Okay. Now the requirement for the remote clears are as follows. You just need a 2 megabit speed data rate connection, and then another thing you need is a directional antenna, a Yankee one, a directional. You don't need the omnidirectional one, because you just need something that can establish a line of sight with the multi-point distribution antennas that on the mounted top or the hilltop. Then another thing you need is a mount, or something you use to mount the antenna. Then the lightning arrestor and a bridge, a wireless bridge. So you need a mount, something to mount the antenna, the lightning arrestor, something that can arrest any lightning that emanating from stardust strike and lightning strike. Okay, so it will not destroy your equipment, your telecommunication equipment. Then a wireless bridge also is one of the things that you need. Now let's quickly take a look at that diagrammatically. Now we say this is a Yankee antenna that is supplying network to your home, and then between that and a bridge you place a lightning arrestor, and then you have a bridge to bring the signal to the home, and then this signal is sent to a hub or a switch. A hub or a switch helps to connect to the different PC in your home. Okay, a hub or a switch helps to connect to the different PCs in your home. So this is what a network administrator have to learn and have to be able to install in the home. Okay, you need a Yankee antenna to bring the signal from the multi-point distribution to your home, and then you need a lightning arrestor to be able to arrest any unwanted signal like a light source, and then you need a bridge to receive that carries the antenna to be able to decode the signal or the data packet, and then you need a hub or a switch to carry the packets, the data packets to the different PCs in your home. Okay, so that's all you need. Okay, thank you very much, and let's move on to the next one. And then the next one is just the chapter summary. What you need, we have talked about in this this section of this chapter. So one of the things we presented an overview of presented an overview of the wireless networking. We provided an overview. The next is that the vendor of the wireless networking, they've done a lot of things. The networking equipment, they've made the use of wireless networking very easy to integrate into an existing network. They've prepared everything just to buy, plug, and install. Buy, plug, and install. That's it. The vendors, the manufacturers, they've done a very nice job. They've done everything. You're not configuring anything anymore. You just buy, plug, and it will install. And you see from your system. You watch it from your system, see how it has been synchronized. Okay. Then but the reader must understand key objectives of the network administrator is to provide, your key objective is to provide what? Provide a fast network, provide a reliable network and a secure one at that matter. Okay, so these are your key objectives as a network administrator, because your vendor has done most of the work for you. The configuration, many things, just plug and install. Now, another thing is that you carefully integrating wireless components into network can easily compromise your objective. So you have to be careful in integrating your components, okay, so that you will not compromise the objective of what you're doing. Now, the still part of the summary, the concept that the students should understand from reading this chapter are as follow. First of all, the students should know the operating characteristics of the 802.11 wireless network. The operating characteristics that we describe in 4.2, 4.3, and 4.4. The students should understand this operating characteristics of IEEE 802.11 wireless network. Another thing that you should know from what you have done so far is the purpose of the access point. Why do we need an access point in a network? Because we've explained that previously, that you need it in order to be able to connect a wireless network with a wired network. And then you should also know the purpose of a wireless LAN adapter. The adapter enables the PCs to be able to read the network or to be connected to the network. So you should know the purpose of a wireless LAN adapter. And then you should also know the wireless bridge. What is the bridge? The bridge brings the networks to the switch and the hubs, which connects to our PCs. So you should know the purpose of all of this in the network, what the role they play in the configuration as a system administrator. Then how to perform a basic site survey on the building. How to carry out a basic site survey. As a system administrator, you should be able to learn how to perform basic site survey. The thing you should look out for, the RF site survey values, the antenna, the type of antenna you should use, and all of these things you should be acquainted from this chapter. Then how to configure the network for user mobility. How to configure the network itself. We showed a simple diagrams of how the network should be configured. Looking at we told you what you need. You need a Yankee antenna, you need a lightning arrestor, and then you need a bridge, and then you need a hub or a switch. Switch is usually better than a hub, and then you need these pieces that you should connect to. Okay, so you should know how this is the array, how it's being done. Okay, then the next is how to plan a multi-point wireless distribution. Multi-point wireless distribution, how to plan it, and the one we put on the hilltop, okay, for multi-users. Now, the last part of the summary of this chapter is that on the final note, the new wireless networking technologies have greatly simplified the planning and the installation process for all the system administrators. Now, anytime you're working with the RF value radio frequencies, there is a chance of an unexpected interference. So you should keep this and noise. Keep this in mind. An unexpected interference and noise. So we should plan a well-planned RF installation requires a study of all known and a search for any possible interferences that might occur. Okay, all known interferences and even the ones we don't know, and noise that we may not even think of now. We should plan them, put them in our planning so that we will have a very superb installation. And RF studies will also include signal path studies that enable the user to prepare a well thought out plan and allow an excellent predictions of received signal level. So as an administrator, you should have a well thought out plan that will enable an excellent prediction of what you are doing so that the signal output or outcome will be an excellent one, not that the signal is a poor signal at the end of after installation. The signal in every direction, it's a poor signal. So you should have a clear plan thought out. You should put interference into consideration. You should also put noises into consideration that may come and interfere with your signal path. Okay, then the bottom line is to obtain a support for conducting an RF study if needed, because there are some area that they will not want you to assess. Okay, the people or the community may be an issue, so you should be able to have a complete support in conducting your RF studies. Is that okay? So this brings us to the end of this section. Thank you very much.